do the other parts that we did not go through. On Friday, we talked about shifting it left and right, up and down. Now today, we're also going to deal with reflection, and we're going to deal with the tangent line. We didn't do any tangent ones. If you notice that, it was all sine and cosine. And we never dealt with the reflection, which means having a negative in front of the sine or cosine words. That's not a big deal. It's not a big issue. All that's still the same. That cosine one that I just had up there, basically instead of starting at the amp on the top, it would start at the amp on the bottom and ride the other way. Okay? So it's not a whole lot of change. So if I looked at something like this that had, let's see, start off with an easy one. Y equals negative cosine of 4x plus 1. Okay, first and foremost, what's the amp? Remember, amp was always the absolute value of whatever A is. So the absolute value would always be a positive, what? 1. Good. To figuring out your period, we're at 2 pi divided by 4. And what is 2 pi divided by 4? Pi over 2. Good. What's the plus 1 do? Moves it up 1. Good. Now, there's a negative in play. And we're going to talk about how that negative gets treated here in just a second. Alright, so now I go to drawing my axes. And since it moved up 1, I'm just going to move that a little bit lower. And my period is at pi over 2. Okay, now what's half of pi over 2? Pi over 4. Good, not pi. Okay, half of a half is not a full. We're at pi over 4. What's half of pi over 4? Pi over 8. Good. What's halfway between pi over 8, or pi over 4 and pi over 2? 3/8 pi. Good. Now we're catching on to how to treat that. Now as far as the midline, I'm going to draw one up. Since I believe Nick was the one who said up moves it up 1, which he was right. Which means then I have amp lines being one above it, one below it, which I need to draw in the one above it. The one below it is the x-axis. So I'm all okay there. Everything about this has been the same so far, right? Nothing's changed. Okay, I moved everything up 1 just like I did on Friday. Now here comes the negative part. This is what you do. On a cosine curve, normally how we start up at 1, or up at the amp, guess what you're going to do? You're going to go in the opposite direction. So instead of starting up, you're going to go down, and it's going to be down here, and it's going to be down here, and the halfway point is going to be up. Then it's going to cross at the same places. So now the cosine curve just gets inverted. So instead of going and making a V, it goes the other way now. That makes sense? That's what the negative does. Right. So if there's a negative in front of the cosine or sine, it's going to go the opposite, or do the opposite thing. So for this particular thing then, when we start it, instead of going up 1, we're going to go down 1. Does that make sense? All right. Now if I give you a sine curve one, where I have y equals negative, let's put a 2 there, sine 2/3 x minus a half pi. No, 2 sine. All right, let's figure out all the pieces. What's the amp? 2. Is there a negative in play? Yes. Now let's figure out the period. What's 2 pi divided by what number? 2/3. How do I do 2 pi divided by 2/3? I multiply it by the reciprocal. So what ends up happening is the 2 pi would be multiplied by 3/2. What happens with the deuces? They cancel out. and you're left with 3 pi. What about shifting? Was there any adding and subtracting going on? Yes or no?
Yes.
Yes. Where, Markel? Outside or inside? Inside, which means it shifts it to the right or to the left. In this case, it goes to the right. How far? Pi over 2. Right. So, since I didn't have to shift it up or down any, putting it right in the middle would be just fine. Now, having a normal one at 3 pi, but now with the new one, I'm going to draw it in black. I got to move everything over a half a pi. So what's a half pi plus 3 pi? 3.5 pi. Does that make sense? Yes, no? Since I had to move it to the right, I just add a half pi. So if that would have been 4 pi, let's say, I'm right here is where I should be hitting it at. 3 1/2 pi. Normally I would have hit here. But what happened? Where did it move? A half which way, Denise? To the right. Right. So if that's 1 and that's 2, I should be hitting right about here at a half pi. Now normally, this thing would have hit, if I was drawing the original one, what's half of 3? 1.5 or 3 halves. But everything got shifted to the right, a half. So what's 1.5 or 1.5 plus a half? 2. So now it's also going to hit right here. Now you told me my amp was 2 units. So 1, 2, 1, 2. Where are the halfway points? Approximately. In between 2 and 3.5. What's halfway between 2 and 3.5? 2 and 3/4. So right about here. At 2 and 3/4. Or if you like the decimal thing, 2.75. What's halfway between a half and 2? 1 and 1/4. Because if you went 1 and 3/4, you'd be almost at 2. Okay? Now here's the difference. Because of the negative, you know how the sine one usually started at the origin, then went up? What do you think it's going to do when it's a negative? Start at the origin and go down. But our origin now got moved over. So it's going to go down here and it's going to go up there. Does this look the same as the last ones or the ones we've been doing last week? If you guys would have did your assignment, would you have seen that same type of curve? Yeah, except for the only difference is that we start going down instead of going up. That's the only change. Everything about it's the same still. Everything that we did on Friday is the same as what we're doing right there. The only difference is instead of starting and going up, you're going to start by going down. On the cosine curve, instead of going up, you're going to go down. Does that make sense? All right. Then from there, you're going to see tangent ones also. So if I have y equals -3, the tangent of x plus 5, is the plus 5 in parentheses?
No.
No. So that means it gets shifted which way? Up 5, right. And how do you find the period? Pi divided by what number? Huh? Where are you getting a 2 from? One. Right. The period, remember, is this number right here. Which if there isn't one there, it's understood to be a 1. What's that 3 do? Remember that all it did was just stretch it out a little bit more. Didn't really actually do anything. Then, as far as the vertical asymptote, that's the pi divided by 2. That's a half pi. So when I draw this, my vertical asymptote over here, if I just make this line go and I'm saying that that's pi over 2, and then on this side, that's negative pi over 2. The difference is, you know how normally I would have hit it like right at the origin and then gone up? Right? What did it say I had to do? Move it
Up 5.
up 5. So instead of hitting here like it normally does, it's going to go up 1, 2, 3, 4, 5 and hit right there. Is there a negative in front of it? Yeah.
In front of 3, yeah.
So then if there is a negative in front of it, instead of it going this way where it went, and you can't even see it like that, what do you think negative's going to do? It's going to flip it over. So it's going to do this number. That's the only thing the negative does, is it just flips it over to the other side. Instead of flowing up, it's going to flow down if it's a negative. Does that make sense? Everything about this so far has been the same. The only difference, really, the new piece is going to be which way it moves. If it flows more downhill or if it starts down as compared to up. Is everybody okay with that?
Wait, so is that all?
Yeah.
You're not going to throw another? You're not going to
No, no more curveballs. You can't hit them anyway. Just like Noah. So, on page 920, we're at 22 to 40 evens.